Students, now we come to our next topic, equation of uniformly accelerated motion. Students, there are total three equations given by Newton. They are, the first equation of motion is V is equal to U plus AT. Second equation is S is equal to UT plus half AT square. Third equation is 2AS is equal to V square minus U square. These equations were given by Newton, and if you see these equations, these are the interrelationship between the terms velocity, that is final velocity, initial velocity, acceleration and time. Similarly, this equation shows the interrelationship between distance, initial velocity, time, acceleration and time, and the third equation shows the interrelation between acceleration, distance, final velocity and initial velocity. Now, we will derive the first equation of motion. Students, here V is final velocity, U is initial velocity, A is acceleration and T is time. To derive this equation, we use acceleration is equal to change in velocity upon time. We can write it as A is equal to V minus U upon T. If this T is multiplied by A, we get AT V minus U, and if I take this minus U on this side, we get AT plus U is equal to V. If you observe it carefully, you can see that it is our first equation of motion. V is equal to U plus AT. Now we come to our second part, that is second equation of motion, which is S is equal to UT plus half AT square. Students, it gives the distance traveled by any body in time t. For this, we use the formula of average velocity V plus U upon 2. We know distance is equal to average velocity into time. So we can express it as S is equal to average velocity means V plus U upon 2 into time t. It can be said as equation 1. From first equation of motion, we know V is equal to U plus AT. It can be said as equation 2. Now, from equation 2, we put the value of V into equation first. That is, we get S is equal to V is equal to U plus AT plus U upon 2 into time t. If we rearrange them, we get 2U plus AT upon 2 into time t. Now, if I multiply this t in the bracket, we would get 2UT plus AT square upon 2. Now, if I separate the denominator, we get 2UT upon 2 plus AT square upon 2. Then, if I cancel 2 by 2, we get S is equal to UT plus AT square upon 2. Then, S is equal to UT plus, this can be written as half AT square, and you can see we finally got our second equation of motion, that is S is equal to UT plus half AT square. Come to our third equation of motion, that is 2S is equal to V square minus U square. Come to our third equation of motion, that is 2S is equal to V square minus U square. Here again we use the formula of average velocity, that is v plus u upon 2. We know distance is equal to velocity into time. So we can write s is equal to velocity v plus u upon 2 into time. This can be said as equation 1. From first equation of motion we know v is equal to u plus at, or v minus u is equal to at. We can write it as t is equal to v minus u upon a. This can be said as equation 2. Now we put the value of t from equation 2 to equation 1. We get s is equal to v plus u upon 2. The value of t is v minus u upon a. We can write it as v square minus u square upon 2a. We know the identity a square minus b square is equal to a plus b, a minus b. On using to convert the above equation into this form, and finally we got s equal to v square minus u square upon 2a. If I multiply the 2a into s, we get 2as is equal to v square minus u square, and if you look carefully, we have got our third equation of motion, that is 2as equal to v square minus u square. Now our next topic is free fall. What does the free fall term mean? It can be explained as when any object falls freely towards Earth's surface only due to the influence of Earth's gravity. In this case, if any object falls from any height and there is only the force which is acting on it, that is the gravitational force of Earth, and there is not any other force which is pulling it downward, or we can say even there is absence of air resistance. In this case, it is called as free fall condition. Here, when any object has fall, it feels a acceleration due to gravity. This acceleration due to gravity is denoted by small g, and it is a constant whose value is 9.8 meter per second square. It has to be remembered the acceleration is having unit meter per second. The acceleration due to gravity, or we can say g, can have a approximate value of 10 meter per second square. Now our next topic is graphical representation of motion. What does a graph means? A graph is shows the relationship between the two variables, in which one of the variables is taken on y-axis and another is taken on x-axis. In this, first of all, I would explain you the distance time graphs. It have three conditions. The first condition is when a body is at rest. For this condition, we take distance on y-axis, time on x-axis. In this condition, the graph obtained is a straight line parallel to x-axis, or we can say a horizontal line. Now, our second condition is when a body is in uniform motion. For this, the graph obtained . is a straight line inclined to x-axis. Our third condition is when body is in non-uniform motion. In this case, we obtain a curve along the x-axis graph between distance and time graph is a curved line. For distance time graph, 2 points to be remembered are: first, these graphs are never parallel to y-axis, and second thing, they are always positive because they are always increasing, not decreasing. Now we come to our displacement time graph. In these graph, the three conditions are same as distance time graph, but we should know that the displacement time graph can be positive and negative, so we obtain the same graph on the negative side. That is, similarly, when the body is in uniform motion, and for when the body is in non-uniform motion, we obtain the curved line in positive direction and curved line in negative direction. Now we take a speed time graph. In the first condition, when the body is at rest, it means v is equal to 0. In this graph, on y-axis we take speed and on x-axis we take time. In this graph, as the speed is 0, we only get the straight line on the time axis or on the x-axis. In second condition, when the body is in uniform motion, or we can say the speed is constant, the graph we obtain on y and x-axis is a parallel line along x-axis in third condition, when the body is in uniform accelerated motion, it means with the speed, the time also increases. The graph we obtain along y and x-axis is a straight line along x-axis which show speed is proportional to time. Now we take velocity time graph. Students, for velocity time graph, all the three conditions are similar to speed time graph. That is, v is equal to 0, it means the velocity is equal to 0, velocity is equal to constant, and velocity is proportional to time. In this, the graph between the velocity and time is same as the first condition, similarly in the second condition, and similarly in the third condition as the speed time graph. The only difference between speed time graph and velocity time graph is that the speed time graph does not consider a direction as it is a scalar quantity, but as the velocity is vector quantity, so the velocity time graph consider direction and magnitude both. Our next topic is equation of motion by graphical method. In this topic, we will derive the three equations of motion. For this purpose, we will make a single graph which will help in deriving all the three equations. The graph is between velocity and time. The point is origin, named as O. If the initial velocity is not equal to 0, then we have to start the graph from any of this point and take it to this point. These points can be named as A, B. Then we will meet this point on the axis named as C. Here this point B meet at this point. The A pointers meet till this point, and we get D, and at last E. Here DC is initial velocity u, and from B to C this part is final velocity v, and OC is on T line, it is T. Now we derive first equation of motion, that is v is equal to u plus a. Students, if we have made the velocity time graph, if this line denotes velocity, if this line denotes time, then the graph denotes acceleration. So we can say acceleration is equal to slope of graph line A B. We know from the formula of acceleration that acceleration is equal to change in velocity upon time. From the graph we can say change in velocity means BC minus DC. BC minus DC upon here time is AD. So if we see the graph, here BC is V and DC is U. Here AD is on timeline, so if we put the value that BC is equal to V minus DC is U and AD is T. If I multiply A and T, we get AT is equal to V minus U, and if we take the minus U at this side, we get V is equal to U plus AT, which is our first equation of motion. Now we come to second equation of motion, that is S is equal to ut plus half at square. To derive this equation, we again use this graph as we used for the first equation. Students, we know this equation gives the distance traveled in time t. In this graph, we can see if this shows velocity, this line shows time, then this area shows distance traveled. So we can write distance traveled is equal to area of trapezium OABC, BC, or if you observe the graph carefully, you can see there are two structures, one triangle and one rectangle. So we can break the trapezium into two parts and we can write S is equal to area of triangle, that is ABD plus area of rectangle OADC. As we know, this triangle is a right triangle, so we can write this formula as half into base into height, and the area of rectangle can be written as length into breadth. If we put the value of the triangle base, that is AD, into height is BD, plus for rectangle we can see the length is OC into breadth is OA. Now according to graph we can see AD is on time t, so we can write it T into BD. BD can be written as BC minus DC or V minus U. So BD is equal to V minus U, and we can write it as BD is equal to V minus U, plus here OC is time and OA is U. we can write it as t, but from the first equation we know v minus u is equal to at. So we can write v minus u as at plus, if we multiply it, we get ut. If we calculate it again, we will get a t square plus ut. Now, if this equation is written properly, we will get ut plus half at square, which is our second equation of motion. Now we come to the third equation of motion. For the derivation of this motion, we again take the help of the same graph which we have done for first and second. We know that the distance covered is equal to area of trapezium OABC. In this, we can write it as S is equal to area under graph, and we can write its formula, that is half into sum of parallel sides into height. If we put the value, we get half. Here sum of parallel sides, here according to the graph there are two parallel sides, OA plus BC, and for this graph in this trapezium the height is OC. If we put their value, we get half. OA is U plus BC is V, that is the final velocity, into OC is on T line, that is time. Now, if we extend this equation, that is U plus V into T, but we have to find the value of T. So, from equation 1 of motion, we know V minus U is equal to AT and V minus U upon A is equal to T. So from here we can take the value of T and put it here. We get V minus U upon A. Students, you know a mathematical identity, that is A square minus B square is equal to A plus B, A minus B. This identity can be used in the other equation, and we get S is equal to 1 by 2 V square minus U square upon A. If I multiply the denominators, we get V square minus U square upon 2A, and if I take this 2A to this side and multiply it, I got 2AS is equal to V square minus U square. If you can see, this is our third equation of motion by graphical method. Students, now our next topic is circular motion, which I have already explained in the first part. Our last part is application of the chapter. It includes all the formulas which I have explained you in this. The first was distance equal to velocity into time. Then second is acceleration into change in velocity upon time. Then our three equations of motion, that were V is equal to U plus AT, S is equal to UT plus half AT square, and 2S is equal to V square minus U square. Students, if you remind this formula, you will be able to solve all the numericals of this chapter. So please remind them so that you can understand and solve every problem related to this chapter. Thank you.